Hey everybody, welcome back to this new episode for the STM32 tutorial. And today we are going to learn from scratch how to acquire a signal to the MCU. So we are going to build a whole program that will help us to understand the inputs to our microcontroller. So from our tutorial perspective, first of all, we are going to review the electrical circuit or connections that we will put here, as you can see in this video, to set up or to have our build. Then after that, what we are going to do is to set up the PA4 as an input, which is connected with this first push button. And with what we will do later on is to control the state of the red LED that we do have here using that push button. So we are going to connect the whole thing together. We are going to repeat again the same exercise by having the PB7 state, which is connected to the blue LED that will be controlled using a different pin, which is the PD9. And we are going to repeat this example as we will see more about the automation of this code and also having a wider review on the peripheral that we are going able to enable actually. After that, the final exercise, we are going to program the PC13, which is connected to the green LED to be as active low. So each time we click on the push button, it will be going low. And this is by changing the value, by reading the value at the PE11. Finally, we are going to have a summary of all what we have done. And for today, the board that we are going to use is the STM32F4 Discovery, and the microcontroller is the STM32F407 VGT6. However, this code can be reproduced on whatever STM32F4 you do have. And we will have a little bit of review at the beginning of the programming so you don't get lost even you do have a different STM32F4 microcontroller unit. So let's quickly go through the electrical connections. So first of all, we are going to connect the port A pin 0 or PA0 with a 220 ohm resistor to a red LED, and that red LED will be connected to the ground. After that, we are going to connect the pin A4 to a push button, which will be connected to a 3.3 volt. Then we are going to connect the port B pin 7 or PB7 to a 220 ohm resistor, and this one will be connected to a blue LED, then to the ground. After that, we will have the pin PD9 connected to a push button, which will be connected to a 3.3 volt. And finally, we will be connecting the PC13 pin to a 220 ohm resistor, which will be connected to a green LED, then to the ground. And just for information, we are adding the resistor so we don't destroy the LED, because the LED would be working only to 2.2 or 2 volt maximum. So we are adding the 222 volt to reduce the voltage applied to the LED. That was all for this part, and now let's jump and start building our code to control this circuit. As we are making the GPIO input from scratch, I would like to start again the program from scratch, so there's a lot of learning on this part of the tutorial. So let's take this program and create a new program or new project, and let's call it GPIO input and set. Good, so let's start with selecting our microcontroller, STM32 F407, and then VGT. And we should have the GTX. That would be perfect for us. Then for the KIMSYS, we select the core, and after the core in devices, we add startup. And with the startup, we do have the warning that we do have, and it requires the C99. This is not an error, but a warning, and we will see immediately how to select that. Even if you click to resolve, this should unfortunately not resolve the situation. So we put OK. We go to the option for target, and in the tab target, what we can do is select version 5 and then select again version 6. That should correct 95% of the warning message that are not really impacting the how the program works. And the C/C++ tab, we go to the language and we select for the language C99. And finally, we go to the debug tab. We select our ST-Link because we are using the discovery which have an S connected directly ST-Link. We go through settings and we confirm that we do have our connection working well with the ST debugger in this debug adapter. And from the SW device, we do have the code or our MCU, so everything is going well. We go to the Flash download tab, and within that Flash download tab, we have to check the reset and run. And this is because when we are going to load our program, this will automatically reset our program and we don't need to push the reset button. And to make it happen, if you do have the latest Keil or UVision version, you need to go to the Pack tab and select Enable. If you do have a little bit older version and you're using it since maybe 2-3 years, you don't need to go to the Pack and select Enable. Okay, let's click OK. OK, and let's jump to our program, have our good practice and put the MCU name, the MCU STM32 F407. And this is a good practice. So if another person is going to use our program, will understand exactly which MCU you are working on. And it will be the, I think 04 should be more than enough. And change a little bit this one from source group 1 to source or up to you. And let's add our new source program, the main. Okay, fantastic. So now what we can do is quickly take a look on the block diagram for the 407 and just try to remember against last tutorial where we worked with the 411. And you can see it has exactly the same architecture from block diagram perspective. It has more GPIO ports, but it has exactly the same architecture. And this is good because there is some free code that we can move from one member of the family to another member. And that's what we are going to do today. So we do have the same architecture. So what we can do, and I kept the previous program, I just can copy the whole thing, including this library, which will play in a very important role in this migration, and paste it here. So let's make it bigger so you can better see it. And let's start with this include library. So if I go inside this document here and I check, you can see for if defined, now it's using this library, this mapping library for all. So let's make it bigger. This mapping library here, which is the STM32 F407XX, that will be using for mapping all the addresses of our buses and peripherals. And if I go to the previous program using the F411 and I go inside this program and open this document and check, and let me zoom, we are selecting here the defined one is the STM32F411. So by adding this library by default, if I go here, we immediately inherit for free all the mapping, all the memory mapping and the structures that will help us to immediately access the memory and the registers. Well, so now let's quickly check about the previous program as a quick reminder. So we set up our GPIO A pin 0 as high, our GPIO B pin 7 as high, but for GPIO C pin 13 as low because we have been commenting this one. So if just I save and build, we can see it's a 0 error, 0 warning. And let me add now the video. What I should see, so we do have the PA0 connected to the LED red, and the PB7 is connected to the blue LED, and the PC13 is connected to the green LED. So if I click to load and load my program, I should see only the LED connected to PA0 and PB7 turning on. And that's what's happening. And to turn the third one, I just need to uncomment my code here and build and just build my code, go back to this video and load it so the three of them are turned on. And this is what I need. Okay, so this is just a preparation. It took a bit of time, but it's a good remember with the good practices. So let's now jump to our first part of the chapter, which will be controlling. So before we control, we need to set up actually the pin. So let's go before this. Let's check, not this one. Yeah, we set up the PA4 as an input. So let's go and start that. So what we do is jump to the reference manual, and the GPIO itself function has been enabled. So when we enabled here in using the AHP1, which one? The port, not the this is the GPIO. What we need is the RCC. If we go to the RCC register, we already enabled this one. We already enabled the port A. So what we need now, so the port A has been enabled, we need to go and enable the mode of being in input. And to enable that, we have to go within the GPIO chapter, within the register, and we do have a mode register. And this is what we have used to control the pin 0 to become an output. So now we are acting on the same register to control the pin 4 as an input. And the input value is the binary number 00. And here, what we need to set is a 00 for bit respectively 8 and 9. And to do so, we can, like we already have seen this before, by doing, let me copy the same logic we used for PB7 or even PC13, but just copying this. Let's add the comment so we can make a clearer comment about this. So for this one, PA4 and just PA4 means port A, pin number 4, and this one input. Okay, and what we need to do is position number 4. I would like to set up the position number 4 as a 00 here and resetting the values. And then this one, instead of having 1, which is the output value, I can just put a 00. And to make my code more visible and more clear for later automation, let's put it like this. And we are setting up our pin number 4 as input. Okay, so this is the first step that we need to do to set up our pin in the right way. Also, would like to change the PA4, so I need to change this one, just the port GPIO A. So this is step 1, and after that, we still need to set up from the output type here as also push-pull. So we are going to use this one too. We should not forget to change that is GPIO A. And this one here, it's just 4 because it's only 16-bit register, and we would like to reset it. So set it up, or set it up as PP or resetting the bit itself. So we went through this 2-1. So this is the mode, and then we change the output type. So we do have an output push-pull. But after that, as we said, our pin, the PA4 or whatever the pin within our circuit, is connected to a 3.3 volt. And to avoid having any noise, we need to have some control using a pull-up, pull-down register. And as we are going to connect with a high value, we need to have this pull-down value for the pin itself, so we don't have any noise when we go down. And for this, we need to use this one. So this register, the pull up, pull down, and we need to apply same. So it's a 32-bit register. We need to apply this time the 10 or 10 binary value. what we can do here is as simple as copying this one. So we can here for this one resetting the values. So and instead of having mode register is the pull up pull down register. And for also here, and we add also same thing, the pull up pull down. And instead of having the 0, it will be the 1 0. Actually it's not the 1 0 because this is hexadecimal value, and the 1 0 binary is a 2 hexadecimal or even decimal itself. Okay, and setting up the pin 4 as a pull down. Okay, perfect. So now we do have everything set up, hopefully right, for our PA4 to be as an input. But we still don't know if it's working well or not. And one of the easy way to debug our program and to see that everything is working well is just by trying to control another pin and see how things is going for it. So we are going to control the PA0 state using the PA4 input value. And this one, we are starting for the first time our while loop, this infinite while loop. We are putting while 1, just running forever. And what we are going to do here is to read the value of this pin number 4. And how we do that? The answer is coming right away, is GPIO Input Data Register, or EDR, Input Data Register, and we need to read the bit connected with the pin itself, and that's the bit number 4. So it's the bit number 4, or that we can connect directly is the 10 hexadecimal. So let's go back here and make an if statement. So if here the GPIO GPIO and we just put here the input data register and the hexadecimal number 10. So if the total, like we have a number from that, then what we can do is set up our PA0 as high. Okay, so let's just get this one and bring it here. And what we can do to make things correct, we need else if it's not high, we would like to turn it off. And to turn it off, nothing simpler than just adding the and putting the tilde or the opposite operator, and this one will turn it low or LED off. Okay, this should be now enough to have our first debugging thing. So let's build our program and check what's going on. So let's bring back the video and my expected image now. As soon as I load my code, the red LED should be turned off, and when I would push the button, it should turn on. So let's load it. Okay, so the LED has turned off, the red one, which is connected to PA0, and now I'll be clicking on the bottom itself. So let's click, and when I click, it's turned it on. This is exactly what I do expect from the functioning of my program. So I'm reading properly the input at the PA4, and I'm changing the value of the PA0 based on the state of PA4. So this is the first step, and we can jump now to the next one, which is be controlling the next PB7 using the PD9. Why I have chosen PD9? Because we have to enable the GPIO D for this one. So let's go quickly back to our reference manual, and we go to the enable EHP1 enable register, and the GPIO D enable register is the bit number 3, so you get it. If I go here and I enable this one, so instead of 7 now, I put an F, and this one will enable also the D GPIO D. So what I will have to do, I can just copy this, and I'm doing this especially so you can see that there is the same pattern repeating itself. And when we are going in the next episode creating function and automate our code, you can see how it's almost the same code is repeating itself. for this one is, we said it's PD9, okay? And for the PD9 here, so I have to change all this one to D. So we are managing the GPIO D register, and I'm checking the number 9 here, the pin number 9, that usually will control the bit number 9 or 18. So by just changing this one, oh, let me bring the video again, sorry. So I just copied the code from PA4 and paste it here, and I've been changing every value from 4 here that was controlling the PA4 to the 9. And that's just to show how easy it becomes to not repeat ourselves. Okay, so now we set up the PA9 and to control the PD9, and we are going to control the PB7. So let's go here again, and what we can do, it's exactly the same logic. So we do have, instead of PA, we are going PD, and we need to confirm about the PD9. Let's play a little bit with hexadecimals. So we go back here, and so it's not, so we go the direction register. So 9 from a hexadecimal perspective is 2 and then 0 0. Okay, so let's put here, so the 2 0 0. And what we need to do then is go back to PB7, just cut this one here and bring it to this loop. So if the PD9 is okay, we would like to have this one on, and so we set up this PB7 as high, and we just change this one to PB, and no, this one PB9 GOP, and we copy this, we bring it here, we put within parentheses just to avoid any issue, and we should set up, which means this will set up our PB7 pin to low or the LED off. Okay, so this should be all to do this, and let's build and let's bring. So you expect again that the blue LED now, the blue shining LED should be turned off and should be changing the state to on when I push the button. So let's build it. Okay, so the first step is okay. It's off, and if I click, it's on. And there you can see, if I click in both of them, PA4 and PD9, the both LED are clicking, and it's exactly what I need. So we do have the right behavior. So let me hide the video again and go for the last part, which is we are going to create an active low using the PE11. So it will be the opposite of the other LED. So we are going to program the PE11 as an input. And again, we go to our reference manual. I guess you start seeing the whole pattern and how easy it is. And the E1 is the bit number 4. So to enable the GPIO E, we need to control the bit number 4 here. And to do so, we go back to our program, and from hexadecimal perspective, this is a 1F. Okay, perfect. So what we need to do then, and we can just copy again our code and apply the same logic. So here it's PE11. Okay, and we just change the GPIO D to E, so we don't mess with the E peripheral, and here we just change the 9 to 11. Each time we do have a 9, which is the position of our pin, to the new position of the pin we want, and this one should be 11, at least we keep some sanity in the comment. Okay, and here we already finished setting up our PE11 as an input, and finally we can copy this one here to have the active low. Actually, what we need to do, it means if the pin is not high or is not sensing any voltage, it should be high. So what I will do, I will cut here this PC13, cut this value from here, and bring it as a default. So this one will be the default here. And the opposite, if we don't have it, so for GPIO like this, and we put here and after that we are going to make the tilt, and here we put just the 13. It's still, we do have a last step, so we need to find GPIO, the position number 11 from hexadecimal perspective, or even like if we don't want to do any hexadecimal thing, we can just put a binary here and put 1 and we push it by 11. That should be more than enough to get this one. So if 1 pushed by 11 should be enough to compare the same thing. Okay, so let's build. Save, sorry, build the code. No error, should be all good. Let's share the video again and load. Okay, so we do have our green LED turned on, which is expected. And what I expect now, by pushing this button, I should see the LED turned off. And this is the behavior I needed to see. Okay, so that was really an extensive review about how this input setup goes. And I hope through like repeating the same detail, you could see the pattern that will take us to the next video, where we are going to automate the whole thing and not repeating this code again and again. So let's now hide and go to the next final step. Let's go here and here and here and jump to the next one and have some summary. So to finalize and to have a final conclusion, first of all, you need to enable, to have an input, you need to enable your specific GPIO port. After that, you have to set up your target pin as an input within the GPIO itself. Then you check that it is not an open drain. Finally, you check the push down state if you are using a high voltage as your reference. That was all for today's video. I hope you enjoyed and you could learn. I really appreciate having you today. Thank you so much and see you in the next episode. Have a very weird day. Bye-bye.